Ever wondered how to build logic in C programming? Well, you're in the right place. Logic in C programming is like the brain behind the operation, the pivotal force that drives the decision-making and controls the flow of the entire program. It's like the conductor of an orchestra, guiding the symphony of code to produce the desired outcomes. Understanding logic in C programming is like learning the rules of chess. It's the strategic layer that determines your success in the game. It's not just about knowing the syntax, the commands, or the functions. It's about understanding how to use these tools to solve problems, to create efficient, effective, and elegant solutions. Logic is, in essence, the art of programming. It's the skill that separates the good programmers from the great ones. So buckle up, because in the next few minutes, you will explore 7 ways to construct logic in C programming. The first method involves using if statements. These little gatekeepers are fundamental in controlling the flow of a program. Imagine you're driving a car. If you see a red light, you stop. If you see a green light, you go. This is exactly how if statements work. In C programming, if a certain condition is met, the program carries out a specific set of instructions. If that condition isn't met, well, the program simply skips over those instructions. It's like saying, if it's raining, take an umbrella. If not, leave it. With if statements, you can make your program intelligent, capable of making decisions based on different situations. They are the building blocks of logic, the first step in creating complex, interactive programs. So start playing around with if statements, experiment with different conditions, and see how they change the course of your program. Now that you understand if statements, let's move on to the second method. Switch statements offer another way to build logic in C programming. These powerful tools allow programmers to select from a multitude of options based on a variable's value. Imagine you're at a crossroad, and you can take different paths based on the direction you choose. That's your switch statement in action. Here's how it works. The switch statement evaluates an expression, which should result in an integral or enumeration value. After this evaluation, the program flows to the case label that matches the calculated value. If no match is found, the program looks for an optional default case. This structure provides a clear and efficient way to handle multiple conditions. It's like having an automated decision maker in your code, swiftly deciding which path to take. But remember, each case in a switch statement should end with a break keyword to prevent the program from executing subsequent cases. Switch statements can be incredibly useful, but there's more to explore. Next, we will discuss loops. Loops are a powerful tool for building logic in C programming. Imagine having a task that needs to be repeated several times. Instead of writing the same piece of code over and over again, wouldn't it be more efficient to tell the program to repeat it for you? That's where loops come in. Loops allow you to execute a block of code multiple times. They keep running until a specific condition is met. The most common types of loops in C are for, while, and do while. For loops are typically used when you know exactly how many times you want the loop to run. While loops, on the other hand, continue as long as a certain condition remains true. Do-while loops are similar to while loops, but with a key difference. They guarantee the code block will run at least once. Loops can greatly simplify your code. The fourth method we will discuss is using functions. Functions are another essential component in building logic in C programming. A function is a group of statements that come together to perform a specific task. Think of them as little machines in your code. You feed them input, they do something based on that input, and then they give you an output. They are like the building blocks of your program, each designed to perform a specific task. Functions help encapsulate logic, which makes your code more readable and maintainable. Instead of writing the same piece of code multiple times, you can simply call a function. This makes your code not only more efficient, but also more reusable. Another advantage of functions is that they can be tested independently. This is a huge advantage when it comes to debugging your code. So remember, when you're building your logic in C programming, don't forget to leverage the power of functions. Functions are a great way to organize your code. Now let's talk about the fifth method, arrays. Arrays can be a powerful tool in constructing logic in C programming. Picture an array as a row of lockers, each with its own unique number, known as an index. The lockers themselves can store all sorts of things, or in programming terms, data. The beauty of arrays lies in their ability to hold multiple values of the same type under a single name, making it easier to organize and manage data. Suppose you're working with a large data set, like the population of every city in the world. Instead of creating a separate variable for each city's population, you can store them all in one array. This not only simplifies your code, but also makes operations on the dataset more efficient. However, arrays aren't just for big data. They're equally useful for smaller tasks, like sorting a list of numbers or finding the highest score in a game. Arrays can help manage large amounts of data. The sixth method we will discuss is using pointers. Pointers offer another sophisticated way to build logic in C programming. They're a bit like the GPS of coding, helping us to find and manipulate data stored in memory. You can think of a pointer as a variable, but instead of holding a direct value, it holds the address of where that value is stored. For instance, when you want to modify a variable within a function, you would use a pointer. The function will have access to the memory location of the variable, rather than a copy of its value. This way, any changes made within the function will directly affect the original variable. Moreover, pointers enable us to work with dynamic data structures, such as linked lists and trees. These structures can expand and contract during the execution of the program, making them highly flexible and efficient. Pointers can be complex, but they are a powerful tool in C programming. The last method we'll discuss is using recursion. The final method to construct logic in C programming is through recursion. Recursion, you see, is a principle that's as beautiful as it is powerful. It's like a magical mirror that reflects itself infinitely. In programming terms, recursion is when a function quite boldly calls itself. Imagine a set of Russian nesting dolls. You open one only to find another within. You open that one and there's another, and so on. That's recursion. It's a way of breaking down complex problems into simpler ones, then solving those simpler problems in order to solve the original, more complex problem. Recursion can be a bit mind-bending at first, but once you get the hang of it, it's an incredibly efficient and elegant way to construct logic. It can help you write less code while accomplishing more. It's like a secret weapon, tucked away in the arsenal of every skilled C programmer. Recursion can be a game changer in C programming. Let's summarize what we've learned. As we've seen, there are many ways to build logic in C programming. We've explored a captivating journey through 7 key methods, each playing a vital role in controlling the flow of a program. We started with if statements, the cornerstone of decision-making, before moving on to switch statements, which provide a more efficient way to handle multiple conditions. The journey continued with loops, the workhorses that repeat tasks until a certain condition is met. Next, we delved into functions, modular blocks of code that perform a specific task, making our code more organized and reusable. Arrays followed, introducing us to the world of grouped data types. We then navigated the intricate world of pointers, which give us the power to directly manipulate memory locations. Finally, we unraveled the magic of recursion, with functions calling themselves in a loop, a technique that can solve complex problems with elegant simplicity. By mastering these 7 methods, you can effectively construct logic in C programming. Stay curious and keep coding.